Okay, so let's try the second problem, guys, for our secant problems. So we have Cressida would like to create a rotating table for her friends and family whenever they come over for the holidays. So given on the illustration below, a visitor, Kenny, found that okay, so Kenny was found at point K, okay, at this point, and IM, okay, is equal to 3x units, and IK is equal to 10. The distance between the table and Kenny is 10 units, and the measurement of OK, okay, of points O and K, this part of the table to Kenny, is equal to x units. Okay, for this problem, we need to find the distance of the table from Kenny at this point. We need to find the value of x. Okay, so for this problem, what formula can we create, guys, using the secant power theorem? Okay, so again, we're going to use the secant power theorem for this problem. Okay, so again, according to the secant power theorem, okay, if we have an outer segment that we can multiply to the inner plus the outer segment of one secant, it's gonna be equal to the second secant's outer and the sum of its inner and outer. Okay, so therefore the equation that we can create for this one, so what's the outer of the first secant? So that's 10 multiplied by the inner and the outer, so that's gonna be 3x plus 10 is going to be equal to the outer. Okay, the outer of the second secant, which is just equal to x squared. Okay, for that one. So that's just gonna be x, okay, for that one. So that's just gonna be x squared for this problem. Okay, because since there is no inner and outer for this one, okay, so that's just gonna be x squared. Okay, so therefore, okay, for this problem, this is gonna be, okay, 10. We have to distribute 10. So that's gonna give us 30x, okay, plus 100 is equal to x squared. And therefore 0 is equal to x squared minus 30x minus 100. There you go. So therefore we have this formula. Okay, and using this formula, using this quadratic equation, we can find the value of x using the quadratic formula. Okay, so we have here the value of a is equal to 1, the value of b is equal to negative 30, and the value of c is equal to negative 100. We're going to try to solve for the value of x for this one. Okay, so therefore, for this problem, we can say that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And since we know that the value of b is negative 30, we can write here negative times negative. That should give us positive 30 plus or minus the square root of negative 30 squared minus 4 times 1 times negative 100 all over 2 times 1. Okay, so this should give us 30 plus or minus 900, okay, plus 400 all over 2. And therefore, this should give us 30 plus or minus 1,300 all over 2. Okay, let's just try to double check that. So 30 squared minus 400, oh no, plus 400. So that should give us 1,300. And the square root of 1,300, so that's just going to give us, guys, so that should give us 30 plus or minus the square root of 10 square root of 13 all over 2. Or we can say it's going to be equal to 15 plus or minus 5 square root of 13. Okay, so these are the two values of x sub 1 and x sub 2. And we can clearly see what value we're going to take for this problem. It should be the x sub 1. X sub 1 should be equal to 5 plus 15 plus 5 square root of 13 meters for this one. So why did we take the first value? Because the second value, 15 minus 5 square root of 13, it's going to give us a negative value. And since this problem requires real-life measurements, therefore we have to use the positive value. And that should give us roughly or approximately 15 plus 5 square root of 13. So roughly it should give us 33.02. Okay, so therefore the value of x for this problem is equal to 33.02 meters. Okay, so the distance between points O and K, okay, on the table is going to be 33.02 meters. And that's how we solved this problem.